Hi everyone. In this maximal flow problem, so as I have already told you that in network models we have other problems as well, like shortest route and minimum spanning tree. But I'm not gonna cover that here because in other section that has not been taught. So there's a high chance that the paper is coming. In the paper you will be getting a question from maximal flow problem only. So I'll cover this. In case you need me to cover the other two topics, just let me know. I'll upload a small video on that as well. Let's understand what the problem says. So basically, it's about you have a start point and then you have a destination. Assume it. Think of a pipeline. So from point one, you have a pipe to point two, which can carry 40 liters, right? So this direction is important. It says that from point one, it can go to point two. The reverse flow is not possible. I mean, if from point two, the liquid can't flow to point one. Okay. So the arrow is critical. So when you are drawing a diagram, don't forget to draw the arrows. And then again, it says that from point 2 to point 5 it can carry a maximum of 10 liters. Okay, so these are the capacities. So 1 2 3 4 5 are nothing but the nodes, and these numbers that you see in the branches are basically the maximum capacity it can carry, or the flow maximum flow potential, right? So yeah, so what the question says, I mean, like, what is the maximum flow you can if you want to if you want to have a network, like if you have a network like this, what's the maximum amount of liquid that can flow from the start point, that is node 1, to the destination, that is node 7? Okay, so how do we solve this? First, identify the paths through which liquid can flow. So you have to note down all such combination of paths, and then you try to find out the liquid flow in those paths. So the first thing I can see is 1 2 1 2 5 7 or 1 2 4 5 7. Okay, so you can, it is always advised that you go from top to bottom so that you don't miss out any path. So yeah, so the first path I actually noted down here is 1 2 1 2 4, then 5, then 7. I'm only going, if you look at the diagram, that I'm only going in the direction of the arrow. So the first path is 1 2 4 5 and 7. So in this, what is the minimum value that you see, like, that can flow along this path? So out of 40, 10, 20, and 30, the bottleneck is here, that is the 10, right? So the maximum flow that can go through this is minimum of all these values, and that is nothing but 10. Okay, so uh, so through this path only 10 liters of liquid can flow. So what I'll do, I'll yeah, I'll just draw the path again, and then I'll do the calculation once more. So if you see from node 1 to node 2, then 10 liters of liquid is flowing. So out of the 40, the maximum available capacity, that is 40, 10 liters is already flowing through this. So I'll write it as 40 comma 10, and here 10 comma 10, here 20 comma 10, and 30 comma 10, because 10 liters of liquid is flowing through this. And in this, if you see, out of 20, 10 is flowing and 10 is available. Here out of 30, 10 liters is flowing and 20 liters is available, and this path is already completely exhausted. So this means that no more liquid can flow from node 2 to node 4. Okay, and the next path, if you see here, is this one, right? 1 2 5 and 7. So the second path, you write in any order actually. If you write this as path 1 and this as path 2, it's not a problem. I mean, like, you shouldn't just miss out any paths. That's the final goal. In path 2, uh, now what I have to do, I have to find the minimum of this. That is, there's only a sorry, 1 2 5 and 7. Yeah. So if you see now, yeah, out of 40, 10 is already flowing, so 30 is available. Okay, so that's why I've written minimum of 40 minus 10, and then here the capacity is 10 and here the capacity is 30 minus 10. So out of 40 minus 10, 10 and 30 minus 10, the minimum value is 10. So the flow through this path 1257 will be 10 liters only. So now I'll update the diagram. So from node 1 to node 2, already it was 40 comma 10, because another 10 liters is flowing through this path 1 2 5 and 7. So I'll add 10 here. So this will be 40 comma 20, and this will be 10 comma 10, and this was 30 comma 10 before, and now it will be 30 comma 20, right? So this path is complete. Then we'll move to path 3. That is, path 3 is nothing but 1 2 4 and 7. So in this path, the problem is, once we are here, so you see 1 2 4 and 7. So path 2 to 4 is already completely exhausted. So no more liquid can flow through this. So that's why I have written that this path is not possible, because no flow is possible through this path. So we'll not consider this. Again, once this is over, you go to path 4. That is 1 2 4 6 and 7. So is 1 2 4 6 and 7. So again, this is not possible because it's crossing 2 to 4. Like we have seen that from 2 to 4 there is no scope, it's completely exhausted. So this path is also not possible. And then path 5, 1 3 4 5 and 7. 1 3 4 5, sorry, 1 3 4 5 and 7. So here you do the same thing to find calculate the flow. You find the minimum of everything. So it's the minimum of 40. That is 1 to you have to go back to the original question to find. So is the minimum of 40 15 20 minus 10 and 30 minus 10. So that is 10. So in this path 10 liters of liquid will flow. So I'll rewrite it as 40 comma 10, because out of 40 quota available, 10 is flowing. And then there will be 15 minus 10. This was already 20 comma 10, so it will be 20 comma 20 now. And this was 30 comma 20 before, so it will be 30 comma 30 now. Okay, now we'll come to the path 6. So you in this path 6, there's nothing but 1 3 4 6 and 7. 1 3 4 6 and 7. So here I have missed the arrows, but make sure you draw the arrows properly, because otherwise it might create confusion at the end. Okay, so yeah, so our path was 1 3 4 6 and 7. 1 3 4 6 and 7. See here, if you see the maximum flow that is possible is minimum of the available flow here is 40 comma 10, this is 15 comma 10, this is 10, and this is 20. So the maximum possible flow is 5, because this is the minimum value, right? So we'll update the values now. This was 40 comma 10 before. Once another 5 liters of liquid flows through this, it will be 40 comma 15, this will be 15 comma 15, 10 comma 5 and 20 comma 5, right? Then the next path is 1 3 4 and 7. 1 3 4 and 7. Here if you see, this is already exhausted, 15 comma 15, so no more liquid can flow through this. So that's why there is no flow possible. Then the eighth path is 1 3 6 and 7. 1 3 6 and 7, right? Here if you see, it'll be the minimum of 40 comma 15, 20 and 20 comma 5. So that is 15, right? So 15 liters of liquid will flow through this. So you update it. So this will be 40 comma 30, 20 comma 15 and 20 comma 20, right? So if you see now, you might see that all the paths are exhausted. You don't have any other paths, right? But a closer inspection tells you that there is another path possible. So there's a catch. Okay, we call that as reverse flow, right? So what happens if you see now, so so it might seem that we have only found out 8 paths, And if someone asks us ki what's the total flow that is possible from point 1 to point 7, we'll add all the flows. Okay, or you can simply see that here there's 40 comma out of 40, 20 are flowing from 20 liters are flowing from node 1 in this direction, and 30 liters are flowing from node 1 in this direction. So from the source there are 20 plus 30, that is 50 liters of liquid is flowing. But if you see, there is one path which we haven't considered yet. So again, I'll write the arrows here, because without the arrows it is very difficult. Yeah. So there is one more path, that is 1, 3, 6, 4 and 7. So you might say 1 to 3 is okay, 3 to 6 is okay, but from 6 to 4, how are you going from 6 to 4? Because this route is actually isn't is opposite, because the arrow that direction is in the arrow direction is from 4 to 6, but we are saying we are going from 6 to 4. Okay, so here comes the concept of reverse flow. In this case, if you see that there is still potential, uh, okay, so think of it like, how do I tell you? So 10 liters of liquid can come through this way, okay, but here the maximum quota that is available is only 20 minus 15, that is 5. Okay, and because here only out of 10 only 5 is flowing, so if that 5 liter of liquid flows from this way from 6 to 4, so this will be as good as 10 minus already 5 was flowing in this direction and 5 liter of liquid goes from this direction, so this will be 5 minus 5, that is 0. So that means uh, in this in this pipe there is no liquid that is flowing. Okay, which is actually possible. So once I solve this, you will find that it might, it might feel intriguing to you that how come a liquid is flowing in the reverse direction. But that is one case which is possible, and once you solve it, you will see that okay, this was totally okay. So let's consider this path as well. So that is 1, 3, 6, 4 and 7. And if you have to find the maximum flow, then what do you have to do? So the maximum flow is the minimum of 40 comma 30, 20 minus 20 minus 15, and then here uh, 5 liters of liquid is flowing in this direction, right? So maximum the negative flow that we can do is 5 in this direction, so that's why I have considered 5. And then in this the whole 10 liters ka quota is pending, so I've written 10. So out of this we can find the minimum value is 5, so the flow through this route will be 5 only. And once I do that, now I'll rewrite it as 40 comma 35, and this was 20 comma 15, so it will be 20 comma 20 now, and this will be 10 comma, so 5 was in this direction, now we are saying 5 liters will be in this direction, they are in opposite direction, so I'll write it as 5 minus 5, so that is 10 comma 0. And then in this was 10 comma 0 before, now it will be 10 comma 5. So now we see that, like this is exhausted, this is exhausted, this is exhausted, this is exhausted. So although there is some quota available here, 20 liters of quota is available here and 5 liters of quota is available here, because the middle rows are already, saturated, so no more liquid can flow from this to this side. So then we can see that okay, this is the end of it, no further paths are possible, and the total flow that is going from node 1 to node 7 is nothing but this is 20 liters and this is 35. So the sum is 20 plus 35, that is 55, 55 liters or 55 gallons, whatever it is. So that's the total flow. Yeah, so this was it. And like I have said, if you want me to cover shortest route problems or a minimal spanning tree, just let me know, I'll try to cover that. Thank you.